All right. Good afternoon, everybody. It looks like we're just about to hit the 1 o'clock mark. So in the interest of everybody's time, we thought we would get things started. Want to thank everybody for joining us for our first webinar of 2019. Looking at my calendar here, I can't believe we're already at the end of January, but that's how things go. So today we're going to be talking about our forecast, which is our 24/7 online condition monitoring unit that we launched about a year and a half ago now. So some of you have probably heard about it, maybe been on webinars like this before where we've gone through how it works and what it does. But today we want to do that, obviously, for those of you who haven't been privy to that, but also kind of show a few of the things that we've updated since we initially put it out there. So we're looking forward to sharing with you guys the enhancements that we've made along the way as we, always continuous improvement, right? So that's what Doug is going to be sharing with us today. Now, before I turn things over to him, just a couple things. Just like with all of our webinars, I am recording this. So I'll have this up on our website a little bit later this afternoon. So you can definitely take a listen to it again, or if you have to hop off early, we'll have that available for you all. Also want to make a point that, especially with this topic, if this is something that you're interested in, that your team's interested in, we can certainly do one of these sessions for you personally. That way you can have kind of that interaction, ask us questions along the way. So just keep that in mind, and again, if you've got team members who aren't able to be on this today and you think this is something that you're taking a look at, we'd be happy to set that up. So just keep that in mind. We do welcome questions. We can't be super interactive and have you guys actually ask them, but we will ask that you type those into the little questions box. I'll keep an eye on those and get those questions asked to Doug when it makes sense throughout. And then, of course, at the end, we'll have some time for Q&A. And then the last thing I always mention, or at least try to mention, is, we are doing this live. So if we have any audio issues or connectivity issues, it is like sub-zero out there. I don't know how that affects systems and things like that. But if we run into any hiccups, just bear with us. We'll try and get things fixed as quickly as we can. But, we definitely enjoy doing these live. So we take that little bit of risk with it. So with that, I'm going to turn the screen over to Doug. So just give us one moment here, and I will let Doug take it away.
Thank you, Maureen. Let me just pull up my presentation here from the beginning. So, good afternoon, everyone. Thank you for joining us today. We certainly recognize that everybody's busy, everybody has a lot to do, so we really, really appreciate you spending, the next 30 or 40 minutes with us to go through mechanical reliability and our UE systems forecast, our 24/7 monitoring system. There's been, for those of you who have seen some of the information about the forecast in the past, we're constantly, improving. We're constantly looking for ways to make it, more user-friendly, to be able to offer better reporting options. So as we go through the presentation, I'll point out a couple of things that are new, like our dashboards you see over here on the right, and our notifications. So again, thanks. I'm going to jump right into it. So I want everybody to just take a second and ask yourself, how do you monitor your mechanical and your rotating assets? And do you think you're doing it right? Some food for thought that I see a lot out in the field is the success of your condition monitoring program based on how many fines you get. Just think about that for a minute. Sometimes I see programs where I say, oh, our vibration program works great. We found 5 bad bearings last month, and our ultrasound program is awesome. We found, 5 bad bearings last month. And you got to think about, is it really the right way to approach it, basing it on fines? Albert Einstein, and I love quotes. Albert Einstein has one of my favorite quotes, is insanity is doing the same thing over and over again, but expecting different results. So think about it. Is your program, your condition monitoring program, is it on a treadmill? Are you just doing the same thing, going out, finding problems, identifying them, reporting them, fixing them, and then waiting to go find new problems? Or are you doing the root cause? Are you taking a step back? Are you looking at maybe what caused these problems, and trying to either engineer them out, try to make sure you're using correct lubricant or you're filtering your lubricants? There's all kinds of things that you should be thinking about and doing once you've got finds from these condition monitoring technologies. So again, just think about that as we go through this. Think about how you're monitoring your rotating and your mechanical assets, and think about it, are you doing it right? And I got a few more quotes coming up for you later. So how do we monitor our mechanical and rotating assets? Historically, two technologies immediately come to mind, and most plants are using ultrasound or vibration or a combination of both. And it's very typical that these are handheld data collectors that, the PDM folks will go out and they'll run monthly routes. And that's been going on for as long as I can remember, as long as I've been in this industry. People have gone out and run monthly routes with either ultrasound or vibration. But we're coming across a lot of challenges now, and one of them is manpower. We see a lot less skilled maintenance personnel in the field that we can actually send out there with these technologies and get good results. It also requires a lot of training, and a lot of commitment by the plants to be able to have people and dedicate them to doing proper PDM. So that's one of the challenges that we come across. It's time consuming. It takes a lot of time to have someone run out and do monthly routes with handheld equipment. Another huge challenge I think we're faced with now is access. And some of it's safety. Some of the plants that we've been in, a lot of the assets they can't safely get to do a route-based condition monitoring program. So, these assets in many cases don't get tested because the safety regulations won't allow you to get near enough to them to take readings. Some of it's also physical. Some of it's more shielding, more guarding, very, very difficult to get in and do the handheld vibration or handheld ultrasound routes. So again, it's something that we've always thought about, and I think technology is really starting to catch up with some of these challenges and come up with some really good solutions to those problems. There's also the need to test some of our critical assets. Do you have assets in your facility that you can't wait a month? Something that may actually shut down a production line, or something that you don't have a replacement bearing or a replacement motor in stock, that would have a critical effect on what you're trying to produce in your plant. So some of these assets need to be monitored all the time. And obviously you can't have a person stand out there and listen to it. You can't have somebody go test it every hour. So, having online or real-time condition monitoring, becomes more and more important. So why ultrasound? What does ultrasound detect? Why do we use it? Ultrasound picks up two things essentially on rotating equipment or mechanical equipment. It picks up friction. So too much friction, too little friction. It's picking up the sound, or the high frequency sound that's created from friction. The second thing it picks up is impact. So if we think about just a bearing, for example, an increase in friction could simply mean that lubrication is broken down and the sound level goes up because there's more friction. If we develop a bearing fault that is a nick on a race or a flat spot on a bearing, every time it goes around, it's going to impact. So the two things that ultrasound is really good at is friction and impact, and it makes it a great technology for early detection. We can pick up changes to the condition of that asset very early on in its life cycle. So why is it effective? Well, ultrasound or high frequency sound detects very subtle changes in amplitude. The transducers we use have piezoelectric crystals that are extremely sensitive to just a very little bit of energy. So we're able to actually pick up subtle changes in the sound level. The other reason ultrasound is extremely effective is because the sound attenuates very quickly. What that means is the sound where it's being produced, for example, a bearing race, that sound is very strong at the source, but it dissipates very quickly as you move away from the source. So the sound's really local to the specific component that you're trying to test. Okay, the other part that makes ultrasound a nice technology for rotating equipment is these ultrasound transducers aren't affected by the overall machine movement and the operation. Okay, they're only listening internal for that friction or that impact. So ultrasound has become over the years a real go-to technology, especially on high overall vibration equipment, where you would get a lot of false readings from other technologies. Ultrasound can be mounted permanently on the housing, and it'll even move in unison with a high vibration piece of equipment. Even something like a shaker, you can mount a transducer on, and we're still only listening for that friction or that impact. We live in the world of decibels. That's really the numbers that we're using to measure an increase in the sound level. And it turns out that measuring the increase in dB over time makes ultrasound a great leading indicator that there's a problem. Just the overall ultrasound level, the overall number, once you've established a baseline, makes it really easy to trend these over time. We're also able to monitor for alarm levels. So by using a dB number and assigning an alarm level, we can basically take the increase, wait till it hits an alarm, and then we can record sounds and we can take action. So trending is really a great application for ultrasound on rotating equipment, and that overall ultrasound level is going to be a very early warning that something's changed and that we need to do something different. So let's talk a little bit about vibration analysis, what it detects, because vibration is also very commonly used on our rotating equipment, and both ultrasound and vibration, have a definite place in a condition monitoring program. So vibration measures displacement, velocity, and acceleration, and it uses all kinds of parameters to do this. It uses sample time, number of samples, number of averages, etc. Typically, the higher the speed, the higher the RPM of the equipment, the less sample and the less number of averages you need to get a good spectrum. The lower the RPM, so when you get into 300, 200, 100 RPM or below equipment, you need a lot more samples to build your spectrum, so that you've got enough to actually analyze it. So really, to get the right data for a certain type of equipment and its failure modes, you really need to be utilizing all these parameters and understand the actual function and operation of that piece of equipment. That said, vibration works extremely well, but only after detailed analysis. Okay, so the level of information we're getting from vibration is amazing. It's fantastic. It can tell you a ton about the asset, but you have to know what you're looking at. So one of the challenges that we're always faced with using vibration is finding somebody with enough experience to understand and be able to analyze the FFTs and the time waveform spectrums. Okay, what if you just want to know if that bearing is good or bad? Well, you still need to analyze the spectrum. So really what that means is that just taking an overall vibration level from a piece of rotating equipment, it's not the best method. The overall vibe levels are just difficult to trust. Vibration really works well when you've completely analyzed the spectrum. So it takes some skilled observation. It takes someone who understands, the waveforms, the FFT and the time waveforms to be able to interpret that data. So typically that's a highly skilled analyst. Again, if we're just looking for friction and impacting, which is going to notify us, hey, do we have something changing? Vibration's not going to be your best bet. So sort of the key point here I'm making is overall vibration level is not a great leading indicator. It's a little bit late. Once you've got high overall vibe levels, the asset's pretty far down the track in its failure mode. So let's talk a little bit specifically about the forecast and what it actually does. The forecast monitors 24/7, 365. It's always listening. So basically, we mount 4 ultrasonic transducers, RAS sensors, up to, in this example, a motor and a pump, could be a motor gearbox, doesn't really matter. And we bring those 4 sensors back into the forecast box. Okay, it's almost like having a person stand over that asset with a handheld device and listen to it all the time, every second of every day. So it listens, and when an alarm happens on any individual point, the first thing the forecast does is it stores that alarm and takes a sound file. At the same time, it's sending that alarm condition via an email or a text to whoever you basically want it to go to. So listens all the time. When you hit an alarm, it's going to send that notification out via an email or a text message. Stores readings on board. In other words, we tell it how often do we want to take a dB level, how often do we want to record a sound file, and it stores those on board the box. So maybe we want to take a reading every day. Maybe we want to take a sound file once a week. We can do that. We just program it via the software right into the forecast, and it does that. The last thing it does, it sends those stored readings over to DMS software for a permanent historical record. Okay, so if the motor's running along fine, nothing happens, we're taking a reading every day, maybe we tell it to send over a stored reading from the box over to the software once a month. The beauty of the system is it's not going to miss anything because it's always listening. So the forecast stores these dB values and sound files right on board the unit at user-defined levels or user-defined intervals. So once we've got that information to send over to the DMS software for analysis trending, we have a couple different options. So we have different ways we can get that information out of the box and get it over to our PC for a permanent record. One is an Ethernet connection. You simply have an Ethernet port on the box, you hook it into the plant's Ethernet, and however often you've told the box to do so, it sends it over for a permanent historical record. We can also use a direct local connection. In other words, we could have the forecast mounted out near the asset. We could have the cables from the sensors and the forecast box, and we can have the information stored on the box, and then via direct connection to a PC, bring up a dashboard so you could literally walk by and see, how many assets are good and how many are bad. The last way we can manage that information is via a wireless router. We can put a router on the box, router on the computer, and we can send that information via Wi-Fi, provided there's good Wi-Fi inside the facility. So it gives you plenty of options to manage that information. I mentioned earlier, the forecast is always listening. So when a point hits an alarm, it stores a dB reading and a WAV file, sends that notification via email or text, and then starts storing the dBs and WAV files at a new predetermined rate. So what I mean by that is if we currently are taking a reading a day and sending it over to the DMS software once a month, when we hit an alarm, we instantly grab a dB level, instantly grab a WAV file, and we can program it to start storing a reading every hour if we want. Again, it's very flexible, very user defined. The last thing it does is it goes back in time and it'll grab readings from before that alarm even took place. So from a root cause analysis standpoint, it gives us the ability to go back and see, did this particular point slowly increase? Did the dBs go up over the course of a week? Or was it running fine and the dBs went up the day before it alarmed or hours before it alarmed? So again, it's almost the video camera in the convenience store. Once it gets robbed, you can rewind the tape and see what happened leading up to the robbery. You can see the guy's casing the joint 2 days before. So when it does detect an alarm, here's an example of that alarm being sent via email. In this case, we can see that the original baseline was 24, alarm level hit our high alarm level of 16 decibels over the baseline, or 40 dB, instantly grabbed a reading and stored it in the box and sent it over to DMS software, but also sent an email with all the detailed information about that specific point. It also, via email, can send a sound file. So having the ability to be notified immediately and be able to listen to the sound file gives you the ability to make better decisions. We also have the ability to send a text. The text won't have the sound file, but it will have all the pertinent information about which specific point entered alarm and exactly what time it entered alarm. One of the real powerful features of the forecast is this ability to be alerted immediately when something goes into alarm, especially on critical assets. So again, the forecast is going to let you go back in time and collect decibel values and sound files leading up to, during, and after the alarm. All of this is user defined inside of DMS software. So you're able to go in and, based on the criticality of the equipment and based on its failure history, you can determine, hey, if it goes into alarm, we need to start storing, or we need to go back and see what happened every day that led up to that alarm. An example would be a point goes into alarm, you go back and look at the last 5 days of information, and it was fine Monday, Tuesday, Wednesday, Thursday. Friday, it went into alarm. Well, you go back and look, and maybe it was on a lubrication route and someone over lubricated it Thursday afternoon, and it went into alarm Friday. So that data from a root cause analysis standpoint is very, very powerful. So let's take a look at what the forecast components are, or what the system consists of. First, we've got a 4-channel box, stainless steel, dimensions probably about 5 inches by 4 inches by about 2.5 inches thick. You've got 4 of our RAS sensors. The exact same RAS sensor is used with handheld ultraprobe devices. So if you've currently got routes set up in your plant, you've currently got RASs mounted that you're, taking monthly readings that, maybe it had access issues, or maybe for safety concerns, you've already installed RAS sensors, same RAS sensor. You could seamlessly just unplug the BNC and plug it right into the box. Mounting studs, we use pretty easy to use click bond system uses a two-part epoxy. You put the epoxy on the surface, put the stud on, you push this plastic down, it holds it in place. 20 minutes later, you come back, pull the plastic off, and you've got a perfect place to mount the sensor. The connection cables, all kinds of cable lengths available. We've got all kinds of standard cable lengths available. We can always custom order cables or make cables as well. Typically, people will just go and do a walkthrough and figure out, what cable lengths they need. And we need a power supply. The system needs to be powered up. So let's take a quick look here at DMS software working with the forecast. The beauty of this is if you're an existing DMS user, let's say you've got a mature ultrasound program and you've got a database set up and you're already using DMS, you can essentially go pull 4 points from your existing database by using pull down menus in the software and put those on a forecast route seamlessly and easy. So by going into our forecast tab in our DMS software, it lets us just go select which application, which group, which particular motor and which point we want to put on the forecast route. If you're a new DMS user, easy enough to go in and create your database in DMS for the forecast. So either way, if you look at the current version of DMS, DMS 6, there's a forecast tab in addition to all the other tabs. Clicking the forecast tab opens up a series of other tabs that lets you customize your setup. It lets us select, which group of assets we want to look at. We can set up all of our data acquisition parameters. So in other words, how often are we taking a reading, how often we store in a WAV file, etc. It also lets us set up our alarm levels based on baseline readings. So real easy. We've got 5 different tabs up here, and I'm just going to go through each one real quick. Oh, here we go. Another quote. By failing to prepare, you're preparing to fail. Another one I love by Benny Franklin. Plan your data acquisition based on information. So what I mean by that is if you've got past routes you've been running, whether it be vibration, whether it be ultrasound, if you've got some information about the assets you want to test, go through that information before you set up your data acquisition schedule in DMS. You want to be sure that you're going to be able to take readings at realistic timeframes and timeframes that make sense based on the failure data that you have available to you. Review what your alarm level should be. Typical alarm levels we use, 8 decibel rise over a baseline. That's our low alarm level. And most of the time that indicates the friction level's gone up, but damage hasn't actually been done to the bearing yet. What we need to do is probably lubricate, and that should bring it down to baseline. Our high alarm is double that, 16 decibels over baseline. And the high alarm in the majority of cases is going to tell us that we're past where lubrication is going to bring it back. We've actually got some type of a fault that's developed, and we're into a failure mode now on that bearing. These aren't written in stone. You might have to adjust these levels, especially if you have VFD drives. The alarm levels may have to be spread out a little bit. You might need to use 10 or 12, or 18 or 20. But again, whatever data you have, apply it to setting up your not only your data acquisition schedule, but what you're using for alarm levels. And have an action plan in place for alarms. Who gets notified by text, by email? And once they get notified, what are the next steps? Is it immediately shut down the equipment? Is it, start testing it more frequently and take a look at it. There's all kinds of different next steps that you can put in place, but have the next steps predetermined so everybody's on the same page. So in this tab, the forecast points tab, this is where you get to set up your own naming convention. We use motor outboard, motor inboard, etc. You're not limited to that. You can come up with your own naming convention if you've already got one that you use. This is also where we can get a reading now. In other words, we can go and hit, once the sensor's activated, we can get a reading immediately and get a reading and a wave file immediately. Really valuable if you've had a bearing or a motor replaced. Very valuable for new installations where you want to hook a forecast up, and before you even get started on data acquisition, you want to go in and get a reading right now. The sensor setup, this lets us bring our sensors online. We get to set our sensitivity parameters. We get to view the baseline. Once we bring the sensor online, we want to see what the baseline is. And this is also where we're going to set our alarm levels. If it's in blue, it's fine. Any point that's in red is going to indicate that it's in an alarm condition. Here's our reading scheduler tab. I mentioned this earlier. How often do we store a reading on board the forecast? How often do we send a stored reading over to our DMS software, for a permanent historical record? And how often do we do this once we've hit an alarm condition? Most of the time, we're going to do it more frequently once we've hit an alarm condition. So we're testing and reading, we're taking readings, during normal operation, and then we're taking readings before, during, and after the alarm took place. And the same thing goes for our sound files or our wave files. Our sound files, we have to tell it how often do we want to record a sound, how often do we send it to DMS. The only different parameter is right here, how long does the wave file need to be. So unlike a handheld device where you can push down and hold a button, or you can set it, you've got to tell the forecast in advance. When I take a wave file, I want a 5-second file or a 10-second file. And when it's an alarm, I want a 15-second file. So again, all user defined, all these parameters are user defined, and it's really easy to get set up. So now we've got a whole bunch of data from our forecast, but we've got it. Now what are we going to do with it? Well, we've got a lot of different options I'm going to talk about. We can view the current status on a dashboard. We can do some charting. We can analyze the sound files that we've recorded via FFT or time waveforms, and we can generate reports. Here's what the dashboard looks like. It lets us see our current condition right now. It lets us filter data. So if we look here, in this case, on the right, we can see how many days it's been since the last reading was taken and which points are actually current. We look at the graph on the left, it's instantly going to give us a visual indication of how many we have in low alarm, how many high alarm, and how many are good. So again, if you had a local display like this, where you have the forecast hooked up to a computer out near the asset, by simply walking by and taking a look at this, you get a good, view of what the condition of that asset is. The dashboards, incidentally, also work in DMS6 for our handheld units. So it's an available way to view on a large route how many points are completed and how many still need to be tested. We can chart the dBs over time and get a visual representation of sort of the history and the condition of that motor or that bearing. We can look at it versus baseline, see if it's hit a low alarm, see if it's hit a high alarm. We can take our recorded sound files, we can bring it into Spectralizer software, and we can do some more detailed analysis. We can look at the FFT in the case of rotating equipment, and we can see where these harmonics are. And based on knowing the speed, the number of balls, etc., the location of the harmonics and how they relate to running speed give us a good indication of what type of a defect it is that we're seeing. Is it an outer race, an inner race, ball spin? Exactly what's happening. Very similar to what you're doing, or exactly what you're doing when you're doing an FFT on, received vibration data. And we can also generate really nice multimedia reports. We can bring in all of our historical data. We can bring in charts. We can bring in screenshots of the spectrums. And because the report's a multimedia report and we can do it in electronic format, we can embed the sound file right into the report. So it can be emailed or stored electronically. You can actually go back and listen to the condition when that wave file was taken. So let's review a little bit. Forecast continuously monitors our critical and tough to access equipment. Obviously, if you've got equipment that you can't get to on a regular monthly route, a great option is to mount one of these RAS sensors on it and bring it back into a forecast system. So you're not going to miss any failures or impending failures. Number two here, I think, is one of the most powerful features of the forecast. It really it lets you take instant action on your critical assets. So getting that email or getting that text notification is, I think, really powerful. Lets us obviously establish how that equipment's behaving. What's going on with it, what was happening with it, what's going on now. The dashboard gives you some local alarm capability. Lets us, the sound files and the DMS software is going to let us chart, analyze our time waveforms, analyze those wave files to pick out specific defects, generate reports so we can get that information out to the appropriate people. We can also integrate that data. It's in a SQL database. We can integrate it right into a CMMS system. So design for success. Start small. The beauty of the forecast system, it's just a 4-channel system. It's easy to get set up. It lets you actually pick one asset that's critical or has safety and access issues and get the program going. Document everything. Review the results with everyone on the team. Share the success. There's going to be opportunities, I think, to use the forecast in plenty of other areas in your facility. It's really just a matter of awareness. It also lets you expand slowly. You can move it to other assets, as long as you have an implementation plan that's realistic. I never like to title any slide conclusion. My personal opinion, there's no conclusion to maintenance and reliability improvement. You are never done. I told you I love quotes. I'll throw a quote of my own out here. Do something, even if it's wrong. Take action. Everybody could use improvement in their maintenance and reliability program, in their condition monitoring program. So hopefully you'll get a takeaway or two from today. Do something.
All right, awesome. Well, thanks, Doug.
Questions?
So we had a variety of questions come in. Some, I've already kind of written you to let you know it's probably something better for us to handle offline. So we'll definitely be in touch with folks about those. But I did have several people kind of asking similar questions around kind of the various applications and what that would mean as far as, for instance, someone was wondering, do we have wireless sensors? And the answer to that is no. So of course, then, how would that work then if we've got like rotating assets or high temperature applications? So maybe talk a little bit to sort of some of those options and how we can kind of build a system that would fit, your specific parameters.
Sure. The temperature one's easy. I'll address that one first. We've got these, what we call a thermal isolation yoke. It's essentially a little radiator, an air radiator that you mount on the motor, on the gearbox, whatever it is that's too hot for the sensor to be on. And then you mount the sensor on it. That'll let you get up to 600 degrees F surface temperature, and you will have no danger of damaging the RAS sensor. So that's an easy fix. We've actually got a lot of those in place currently, and being used, and they work extremely well. So yeah, it's called a thermo isolation yoke, and it's easy to mount, easy to use. It's just a little air radiator. It has some fins on it, and it reduces that temperature down. As far as wireless, we can take a wireless router out of the forecast box and put a wireless router on the computer, and you can certainly send the data and the sound files, via Wi-Fi. As far as the sensor itself has to be wired. So the sensor itself needs power. It's getting the power from the box. So we mount the sensor. We've got people using them on robots, people using them on cranes. So it's easy to mount them up, and you just have to watch your cable lengths. In some cases, we've got people using the RAS sensor with just a 8-inch, 12-inch cable length, and putting the box and the sensors right on the asset that's moving. So that's an option as well.
All
Other
right, sorry, I had
questions?
to take myself off mute there. So someone's curious, are we looking at any options down the road to where the forecast, instead of being currently, a 4-point system, to maybe an 8 or 16, or increasing that number of points per box?
We're always looking at things like that. It always comes down to the forecast box. It's not just an empty box. It's got electronics in it, and to be able to do all the functions that it does, it takes a lot of processing power. So right now there's a lot of electronics in that box. So what would probably happen is to have multiple channels, you'd need the box to be a lot bigger. And yeah, we're always looking at things like that, though. So yeah, there's possibilities down the road. We'll add channels to it.
All right, and one more. I don't know, what if we've got any experience with this, since it's still pretty new and customers are still getting their arms around it. But someone was curious about how you could utilize the forecast in conjunction with a lubrication program, and perhaps even have, the different alarms trigger like an automatic luber. Is that something that we've heard from any of our customers that they're doing, or do we think that's something we could envision working?
They're not doing it yet, but certainly, when you start looking at a system like this that's an automated system, naturally the idea of doing that comes up. And we're in discussions with a ton of people about it. I think we're just too early. I'm not even trying to avoid the question. I'll just address the question straight up. We're early enough on that we don't have an answer to that yet. Does it sound like something that'll work? Absolutely. Sounds like electric cars will work too, but time will tell. We'll see as we move forward if that's something that people want to do, and if it'll be effective.
Cool. And is there a limitation on the number of forecast boxes that can be part of a system?
Nope. You have as many as you want. You can even daisy chain them together with one Ethernet connection. So you don't need a separate Ethernet drop for every box. We've had that question come up. You can just hook the boxes all up together in one Ethernet connection, and it'll still go find each box. But no, you can have as many as you want.
All right, cool. And then someone is curious about how you could do monitoring in an electrical system. So maybe if you want to, I know it's a little different than what we're talking about now, but maybe talk about that.
Yeah, that's a different product altogether. We've got a system that does that gives you a voltage out, or an audio out. But I could certainly address that offline. We can, get me the information, and I'd be happy to talk to that person a little bit about that product. It's an ECM 586 electric cabinet monitor.
Perfect. Just wanted to use that as a little teaser that, there are other ways to use the ultrasound. So stay tuned. I think we're definitely going to do some electrical application specific webinars in March. So kind of keep an eye out for that. So that was just my little tease. So anyway.
Okay.
All right. Well, that was great. Thank you so much. Great questions. And we got through quite a few of them. Like I said, those of you that I've kind of written that it's definitely worthy of a longer discussion to fully answer your questions. We will do that offline when we get done with this today. So just look to hear from us on that. I'm going to take the screen back.
We can also jump in, and certainly I'd be happy to go into a lot more detail on the software setup and how to set those parameters for anybody who's interested, Maureen. I'd be happy to spend time with them and go through some more on the software and what they can expect to see if they have a system up and running.
Definitely. So like I said at the beginning, if this is something that you think you guys are seriously looking at or even somewhat seriously looking at, we can definitely do one of these sessions, one-on-one with you and your team, where you can really jump in and interact and ask questions, and we can dig deeper into your specific applications and things like that. So keep that in mind and definitely reach out to us and we'll make that happen. So just some kind of closing slides before we let everybody go. And again, appreciate everybody's time. One of our favorite times of the year, Lubruary, it's coming. Actually, technically starts tomorrow. So for those of you, and I know some of you are asking questions about lubrication, February is the month. We focus all of our webinars. We'll have 3 of them on everything, bearings and lubrication, and how you can utilize ultrasound to improve those practices and enhance your bearing life and things like that. So we love it. It's the month we show our bearings some love. So we'll start getting the information out for that early next week. So if that's a topic of interest for you, we've got you covered next month. So look for that. Also want to make you guys aware of our conferences that are coming up. I certainly am dreaming about being at Clearwater Beach, Florida right now, since it's just absolutely frigid outside. But we've got some really awesome content already planned, some really awesome customers who are going to come and share their success stories with the various applications with ultrasound. And then, of course, some really awesome thought leaders on the Reliable Asset World side, talking about things like asset criticality and root cause analysis and really building a reliability program. So just really good content, great location. So if you've got some dollars in your training budget, we'd love you to come on down and spend some time with us at the beach. So make note of that. And then I will leave our contact info up here. So definitely don't hesitate to reach out. We love talking about this with folks. That we're excited to see where it goes and see how our customers are going to be using it and the success that they're going to have. So we hope you'll be a part of that. And yeah, thanks again, Doug. And we'll look forward to seeing you on another webinar here real soon. So everybody have a great day, and we'll catch you guys later.
Thanks, Maureen.